So here we have a typical 3D trig problem involving a triangular prism, and the question gives us various dimensions. So let's write those onto the paper, onto the question first. So it tells us that AB is 120, so we write that on here. FC is 90. They're all centimeters, so I'm not going to bother writing on the units. BC is 30, and angle FCB is 90 degrees. So the cross section is a right angled triangle, and they want us to find the angle between EB and DCEF. That's the base here, and this distance here, EB, which is not drawn on, so I'm going to draw that on. I'll draw that on in blue. So they want this distance here, and the angle with the base, so the angle will be to the right angle triangle down, the right angle here. So it's this angle here. So I have this triangle here that I'm trying to actually solve, this right angle triangle, where the base of the triangle is the diagonal of the base DCFE, and then the height of it here is 30 BC, so I did not need to worry about the hypotenuse of the right angle triangle. I just need two measurements to find my missing angle here. So the first thing I'm going to do is try and work out this distance EC. If I look at my dimensions, if this is 120, AB is 120, so is DC, and importantly, so is EF. So I'm going to write that on here. So that's going to be 120. So therefore, to find the measurement EC, I'm going to be using Pythagoras. So EC is going to be equal to the square root of EF squared plus FC squared, which is the square root of 120 squared plus 90 squared, which should work out to be 150 centimeters. So I will write that onto my diagram here, 150. Now I have two lengths. I'm looking at my right angle triangle here, this angle. So I've got the opposite and the hypotenuse. So opposite and the hypotenuse is tan. So the tan of my angle, so I'm going to call my angle x. Tan of x is equal to the opposite, which is BC over the hypotenuse, which is EB, which is 30 over 150. So x is equal to tan to the minus 1 of 30 over 150, and therefore x equals 11.3 degrees to the nearest decimal place. So in this question, we're given a square-based pyramid, and we are asked to calculate an angle between the diagonal of the base and one of the sloping edges of the pyramid. So we are looking at the diagonal of the base, which is this distance here, and then the sloping edge would be this here. So let me put the measurements on, and I'll mark those two lines on as well. So the measurements are: the perpendicular height is 12. The perpendicular height is going to be something like this, coming down here to the middle, and that distance is 12. And we know the area is 64, so the length of the side must be 8 centimeters, because 8 eighths is 64, so I can just write that on there. I'm not putting centimeters because that's just the units I will be using, the same units throughout. Now I want to know the angle between the diagonal of the base, so that's the diagonal of the base here, and one of the sloping edges. So if we go for this one here, like this, you can see now that I have created a right angle triangle with my height here. So to calculate this, I need to know one of the sides. So I'm going to work out this distance here. I work out which is half of the diagonal of the base. And then with this length and this length, I can use trigonometry to find this angle here. So to find the diagonal of the base, it's a right angled triangle of sides 8 and 8. So I use Pythagoras. So I can call the diagonal, I'm just going to call it diagonal, is equal to the square root of 8 squared plus 8 squared. And that's going to give me the square root of 64 plus 64, which is root 128, which is a horrible number, and it's going to be 8. I'm going to leave it as 8 root 2, leave it as a surd form there. Now, I don't want the whole of that, because that's the distance that goes all the way across here. I want half of it. So I want the base of my triangle. So the base of triangle is just half of that. So it's 8 root 2 over 2, which is equal to 4 root 2. My angle I'm going to call x. So if I have 4 root 2 here and 12 going up, I've got the opposite and the adjacent, which is tan. So I can say that tan of x is the opposite, which is 12, over the adjacent, which is 4 root 2. Let's just tidy that up before I do anything else. So that's tan of x is equal to 3 over root 2, because 12 divided by 4 is 3. So x is equal to tan to the minus 1 of 3 over root 2, which then equals 64.7, and then it goes 6 and something else. And that's degrees. And if you look at the mark scheme here, it's rounded to 1 decimal place, so that will be 64.8. In the exam, they will be fairly lenient in terms of your rounding, so my advice would be is to write the whole thing, and then write your rounded answer afterwards, and you should gain the full marks for this sort of question.